Hello everybody and welcome to Notes 8.6. So today we're going to be talking about solving rational equations. So let's go ahead and get started. So a rational equation is any equation that contains at least one rational expression. So remember, a rational expression, we're just talking about fractions here, okay? And we're talking about fractions that have x's in the numerators or the denominators. So when we look at this first example that it gives us, our rational expression here is 1 over x. So since this has a rational expression in it, it is a rational equation. For this lesson, if you guys have two different colored pens, pencils, I highly recommend taking that out, as well as with a highlighter. So let's get started. So to solve rational expressions, what you're ultimately going to do is we're going to clear the fractions. So we clear the fractions by multiplying both sides by the least common denominator. And then once we do that, we collect like terms, isolate the variable, and solve. Always, always, always check for extraneous solutions. And it says, by multiplying each side of an equation by an algebraic expression, it is possible to introduce extraneous solutions. So be sure to check all of the solutions in the original equation to confirm that they are actually solutions. All right, so we're going to look at A. So looking at this guy, I want to figure out what's my least common denominator. So technically this -2 is over 1. So I have 5, 4, and 1. So what is the lowest number that 5, 4, and 1 can all multiply into? Okay, so hopefully you guys realize that's going to be 20. I'm going to rewrite this. So x minus 2 over 5 minus x minus 5 over 4 equals -2. So now that I know my least common denominator is 20, I'm going to go ahead and multiply both sides by 20. So again, whatever we do to one side, we always have to do to the other side of the equal sign to keep it balanced. All right, so when this happens, this 20 and this 5 are going to simplify, and we're still going to have a 4 left. So we're going to have 4 times this x minus 2. So I'm going to have 4 times x minus 2. And then we're going to have minus. And then again here, this 20 and this 4 are going to simplify to become a 5. So then we still have 5 times this x minus 5. And -2 times 20 is going to give me that -40. All right, you guys should know what to do next. Let's distribute. Just be careful when distributing this one. Make sure you distribute the negative as well. So distribute, distribute. So we're going to end up getting 4x minus 8 minus 5x plus 25 equals -40. Okay, let's go ahead and combine our like terms. So I have 4x minus 5x gives me -x. I have 25 minus 8 gives me 17 equals -40. Go ahead and subtract that 17 from both sides. So I get -x equals -57. And then to make it positive, we need to divide each side by -1. So we get x equals 57. Okay, this guy's not going to be extraneous because I didn't multiply both sides by an algebraic expression. 20 is just a number. So it's not going to create an extraneous solution. But where we really want to check for the extraneous solutions is that at no point in time will any of these denominators equal out to 0 or be undefined. So this guy, we're good. All right, let's go ahead and look at the next one. So we have to figure out what is my common denominator. This one's pretty straightforward. They have the same denominator. So since they have the same denominator, the common denominator is x plus 2. So we have x squared plus 2x minus 3 over x plus 2. So we're going to go ahead and clear the fraction by that common denominator. So I'm going to go ahead and multiply both sides by x plus 2. Okay, this one's super painless, gonna cancel and cancel on both sides. So all I am left with is this x minus 1 equals x squared plus 2x minus 3. Okay, I want you guys to see here. So here I went ahead and I multiplied by that algebraic expression. So now there's a possibility that an extraneous solution was introduced. So when we get our answers here, we need to double check that both of them work. So let's go ahead and solve this. This is a quadratic. To solve a quadratic, we need it to equal 0. So I'm going to go ahead, add 1 to both sides, and subtract this x from both sides. So now we have 0 equals x squared plus x minus 2. Okay, we want to factor it, so I'm asking myself what multiplies to give me negative 2, adds to give me positive 1, and that would be positive 2 and negative 1. So this guy is going to factor to become x plus 2 and a x minus 1. Solve it, set them both equal to 0, so I'm going to get x equals negative 2, x equals positive 1. Okay, this is where we need to double check. Do they actually both work? Checking the negative 2. Negative 2 is not going to work because if I put a negative 2 in these original ones, I'm going to get 0 as denominators. And that is not, it's not good. It doesn't work. So negative 2 is an extraneous. Okay, let's double check 1, make sure 1's good. So if I put 1 in those denominators, I'm going to get 3, and we're going to be good. They won't be excluded from the domain. So x equals 1 is my answer. All right, next one. Okay, tiny bit more challenging. So again, let's rewrite this. That x is technically over 1, so I have x over 1 minus 12 over x equals, and technically 1 is over 1. Okay, so I'm looking for the common denominator of all these, 1, x, and 1. So the common denominator would be x. So I'm going to go ahead and multiply both sides by this x. So on this first one, nothing's going to simplify or cancel, so I'm going to get x times x, and x times x is x squared. Now I'm going to, this x and this x will cancel, so I'm just going to get a minus 12 equals, and 1 times x is going to give me x. So again, at this point, because I went ahead and I multiplied by that algebraic expression, there could have been an extraneous solution introduced. So we have to just always check that they both work. So let's go ahead and solve this. Again, we have a quadratic. So since we have a quadratic, we want it to equal 0. So we're going to get x squared minus x minus 12 equals 0. So I just moved over that x. Multiplies to give me negative 12, adds to give me negative 1. That would be negative 4 and positive 3. Okay, solve. So I'm going to get x equals 4 and x equals negative 3. Check if they both work. So really the only restriction I have is x can't be 0. So these both should work. We can double check and just make sure they work. So we have 4 minus 12 divided by 4 is 3. So 4 minus 3 is 1. Beautiful, 4 works. Let's try negative 3. I have negative 3. Negative 12 divided by negative 3 is positive 4. So I have negative 3 plus 4 equals 1. Perfect. They both work. So both of these are solutions. All right, I want you guys to go ahead and pause the video and try B. All right, so for B, again, I have x over 1 plus 6 over x will equal my 5, which is technically over 1. Common denominator between 1, x, and 1 would be x. So I'm going to go ahead and multiply. I'm just going to do it all in 1. I'm going to multiply the whole thing by x. Just make sure that you literally multiply every single piece by x, and you'll be good. So this first one, I'm going to get x times x gives me x squared. X times 6x, so x times 6 over x, the x's will cancel, so I'll get just a plus 6. And then x times 5 will give me a 5x. Again, quadratic, we want it to equal 0, so we're going to have x squared minus 5x plus 6 equals 0. Factor, I'm going to get x minus 3 and an x minus 2 equals 0, because negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. Solve it, I get x equals 3 and x equals 2. So again, similar situation here. The only thing x can't be is 0. These aren't 0, so they should work. We can confirm, though, if we did 3. So this would give me 3 plus 6 divided by 3 is 2, so 3 plus 2 is 5. And then if we did 2, we would get 2 plus 6 divided by 2 is 3, so 2 plus 3 equals 5. They both work. So they are both solutions to this problem. All right, now we're going to take it up one step further. So looking at this guy, we have 3 denominators. 2 of them are the same and 1 is different. So x plus 1 plus 3x plus 4 equals... Okay, so what is the least common denominator? So this one's a little bit different. So notice here I have 2x plus 4s and then I have an x plus 1. Remember, in the worst case scenario, you can always multiply these together and you'll always get a common denominator. But I already have this one, so we don't need 2 of them. So you just need 1 of each. So I need an x plus 1 and I need an x plus 4. Okay, so I'm going to multiply by x plus 1 times x plus 4. Like so. Okay, this should eliminate all of my denominators. If it doesn't eliminate all your denominators, then you don't have the least common denominator. So, this first guy, let's see here. So we have this x plus 1. So the x plus 1 and the x plus 1 are going to cancel. So what I'm going to be left with is this x plus 4 times this x, or x times x plus 4. So that's what I'm going to write down. I'm going to have an x times this x plus 4. Okay, looking at my second one, we'll put a plus. So on the second one, the x plus 4 and the x plus 4 will cancel, so I will have this x plus 1 times 3, or 3 times x plus 1. So I'm going to get 3 times x plus 1 equals this other side, x plus 4, cancel, cancel. So I'm going to have x plus 3 times x plus 1. All right, and now we're just going to go through and multiply it all together, combine like terms, solve. So we're going to end up getting x squared plus 4x plus 3x plus 3 will equal, we have to FOIL this together. Hopefully you guys are okay. I'm going to do this in my head. So I'm going to get x times x is x squared. And then I'm going to get an x times 1 is x, and then a 3 times x is 3x. So I have 1x plus 3x is 4x. So I just did that step in my head. And then I'm going to get 3 times 1 is 3. If that confused you, just write it out and combine your like terms. All right, now we want to move all of my x's to one side. Oh, we'll just combine like terms. Let's just combine like terms. So I have x squared plus 7x plus 3 equals x squared plus 4x plus 3. Okay, I'll go ahead, subtract an x squared from both sides, and that's actually going to eliminate an x squared on both sides. I'll subtract this 4x from both sides, and I'll subtract this 3 from both sides, and those are also going to eliminate. So all I have left now is I have 3x, and then on the other side I have 0, so 3x equals 0, so that means x equals 0. Let's double check and confirm that this works. So this guy couldn't be -1 and it couldn't be -4, so we should be good to go. But if we want to go on, we can do more. So I'd get 0 divided by 1 is 0, plus here I'm going to get 3/4, and over here I'd get 3/4. So it works. All right, let's go to our next page. Okay, so solve this guy. If you guys have 2 different colored highlighters, this might come in handy. So, the first thing you want to do is on this denominator, make sure your denominator is in all linear factors. So that's the first thing I'm going to do. I'm going to go ahead and factor this x squared minus 9. So we're going to have 2 over x squared minus 9 is really x plus 3 and an x minus 3 plus 5 over x minus 3 equals 3 over x plus 3. Okay, so we want to find my greatest common or my least common denominator between x plus 3, x minus 3, x minus 3, x plus 3. So notice I have an x plus 3 and an x plus 3, an x minus 3 and an x minus 3. So we're able to just multiply by this denominator, because if I multiply by this denominator, it will eliminate this one, and then it will eliminate that one with that. So we're going to multiply both sides by x plus 3, x minus 3, x plus 3, x minus 3. All right, so again, on the first one, cancel, 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 cancel. So it's going to completely cancel this, and we're just going to have 2. Plus, on this next one, the x minus 3 and the x minus 3 will cancel. So I'll still have 5 times this x plus 3. So I'm going to get 5 times x plus 3 equals, other side, x plus 3 and the x plus 3 are going to go ahead and cancel each other out. So then I have 3 times this x minus 3. So 3 times x minus 3. All right, distribute, combine like terms, the whole thing. So I'm going to get 2 plus 5x plus 15 equals 3x minus 9. I'll combine my 2 and my 15, so I'm going to get 5x plus 17 equals 3x minus 9. We want to put our x's on one side, everything else to the other side, so I'm going to move that 3x, and then I'll subtract that 17. So now I have 5x minus 3x is 2x equals, and I have negative 9 and negative 17, so that's going to give me negative 26. Divide by 2, divide by 2, so we get x equals negative 13. And again, negative 13 will work because we just can't have negative 3 or positive 3, so this will work. It is not extraneous. All right, word problem. A boat travels 246 miles downstream in the same time that it will take 180 miles upstream. The speed of the current in the stream is 5.5 miles per hour. Find the speed of the boat in still water. So we're just trying to find what is the speed of this boat. Okay, so if I'm going upstream, it says I go 180 miles. Okay, and what would be that rate? So we're going a certain rate. So we're going, I don't know, like I'm just making something up. I'm going 20 miles per hour, right? But when I'm going upstream, I have a current pushing against me, working against me. So I'm actually going to be going slower than 20 miles per hour because a current of 5.5 miles per hour is pushing me the opposite direction. So when I'm going upstream, my rate is going to be minus 5.5 miles per hour because it's working against me. So I'm going slower in t amount of time. Okay, when I'm going downstream, I go 246 miles. I'm still going at the same rate, whatever it is, 20 miles per hour, let's say. But the stream is also pushing me. And the stream is pushing me 5.5 miles per hour. So I'm going an additional 5.5 miles per hour because of the stream in some amount of time. Okay, just so we know, time is equal to my distance divided by my rate. So time is equal to my distance divided by my rate. So we can set up a proportion, okay? Time equals time. So this is the same amount of time. So t equals t. So I'll write that. So t equals t. But we can go ahead and replace that with d divided by r. So d divided by r equals d divided by r. So my distance, 180, divided by my rate, r minus 5.5, is equal to my distance, 246, divided by my rate, r plus 5.5. So I just used substitution. Okay, and we want to eliminate our denominator, so we want to find our least common denominator between these two. There's just two of them, and they're both different, so we just multiply those together. So I'm going to have r minus 5.5 times r plus 5.5 to eliminate my denominators. So when that happens, minus 5 and minus 5 will cancel. So I end up getting 180 times r plus 5.5. So I'm going to get 180 times r plus 5.5 equals, and then I'll get 246 r minus 5.5. Okay, because these two cancel, so this times this. All right, and then we're just going to go ahead and do our math. So we're going to get 180r plus, and then 180 times 5.5 is 990, equals 246r minus, and then 246 times this 5.5 is 1353. We want to move our r's all to one side. I always move my smaller ones, so 180r minus 180r. And then everything else to the other side, so I'll add 1353 plus 1353. So I get 2,343 equals 66r. And then we'll go ahead, divide by 66, divide by 66, plugging that into a calculator, and we'll just round one decimal place. We're going r equals 35.5, and we're going miles per hour. Okay, miles per hour. All right, last two calculator questions. So for this one, I'm just going to talk through this one, and then the second one I'll actually do on a calculator. So this is a calculator. This is a screen of a calculator. To plug this in, you go to your y equals, and in y1, you would put in x plus 2 divided by 1 minus 2x. And that gave us the graph, this graph, the one with the two branches, the rational function graph. Okay, and then we want to know when it equals 5. So then we would, in y2, we would just plug in 5. And that gave me this horizontal line, y equals 5. And to see where these two are equal to, we're looking for this intersection right here. So we're looking for that intersection, which it's already figured out for us. So then we use the intersect feature. And when we use that intersect feature, it already found it, we would get x is equal to 0.273, rounding 3 decimal places, when y is equal to 5. So the answer to this would be x equals 0.273. Okay, I'm not even going to do this on a calculator. We can do this by hand, actually. It's pretty simple. Okay, so let's try this next one. Okay, so for this, oh, just kidding. We'll need a calculator. Dang it. That's okay, but we can, for the most part, graph this. So this guy right here, let's graph him. He has a vertical asymptote, comes from our denominator, so there's a vertical asymptote at x equals -2. So we'll go to x equals -2 and draw in a vertical asymptote. And then this guy would have a horizontal asymptote. So remember, it goes top heavy, bottom heavy, evenly distributed. This is evenly distributed because they're both linear. So you take the leading coefficient over leading coefficient. So that's 1 over 1, which equals 1. So I have a horizontal asymptote at y equals 1. Okay. Then you guys have branches, remember? So your branches will either be here and here or here and here. So let's check where these branches are. Let's just pick a point. Let's pick 3. So I get 3 minus 3 is 0. And then -3, sorry. -3 minus 3 is -6. -3 plus 2 is -1. So we get -6 divided by -1's positive 6. So I would have a point at -3, positive 6. So this branch would go like this. Again, this is just a sketch. We could pick 0, I guess could be nice. 0 minus 3 is -3. 0 plus 2 is 2, so I get -3 halves. So that's right here. Let's go ahead and get our other intercept. So our other intercept would be at 3. Take your numerator, set it equal to 0. So that's going to give me 3. Okay, connect those. Okay, and then we want to know when it's at 1/5. I am not going to be able to draw 1/5 in here. But we want to see, where does this cross with the line 1/5? And I'm probably not going to be very good at this, but 1/5 would be like right here. Something like that, okay? And then to find that, we have to actually use a calculator. So in our y1, we're going to put x minus 3 over x plus 2. In our y2, we're going to put 1/5, and then we're going to find the intersection. Okay, so calculator. I'll be using this one. Let's clear it out. Go to your y equals. Clear that out. So in y1, use parentheses. So I'm going to get x minus 3. So where's my x button? X minus 3. Close the parenthesis. Divided by, use another parenthesis. X plus 2. X plus 2. And then in our y2, we're going to put 1/5. We're going to go ahead and hit graph. Oh, I have a stat plot on mine. Let me clear mine out real quick. Let me turn off my stat plot. Okay, so hit graph. Here it is. Let's zoom in. I'm not zooming very evenly, but I'm looking for this intersection right there. So not quite sure how to do it on here. Trace. Can we use the trace function? There we go. And when I hit that trace, and if you guys are actually using a real TI-84, this is where you go to the second calculate or the second trace button, and then you go down to intersect, and then you do first curve, second curve, enter, enter, and then you'll get this. So it tells me, and if you guys see up at the top of my screen, it says x equals 4.25 when y equals 0.2 or 1/5. So the intersection of this guy is 4.25, comma 1/5. So it's crossing right about there. And my drawing wasn't that terrible. All right, and that's going to go ahead and conclude our notes for 8.6. I hope you guys all have a wonderful rest of your day.